Okay, so we have number 9. This is Andy, Justin, and I. And we have an electric dipole, and it's formed by separating 4.5 nanocoulomb. So we'll write that, and that's Q. How's that Q? Q is equal to 4.9 times 10 to the negative 9 coulombs. And those are the charges. And then it's a plus or minus charge, of course, because it's a dipole. And then they're 0.0015 meters apart, or 1.5 millimeters. So if it lies in a region of an electric field of 2.2 times 10 to the 5th newtons per coulomb, so we can write that as the field, and that's equal to 2.2 times 10 to the 5, that's newtons per coulomb. We're asked to find the maximum torque, so write that down. So if you go to your equations sheet under lesson 5, we have the formula for torque, and torque is equal to the moment, which is P, and that is crossed with the electric field. Remember, this is a cross product here, and that's with the electric field. So we can find P with the information that we've been given. If you go to the same equation sheet, it's right next to it. The moment is equal to the charge times the distance that separates them. And then we can go ahead and plug that into our torque equation. So we have torque is equal to the moment cross the electric field, and we can go ahead and switch that out for this Q and S. So because we're finding the max torque, we can assume that we can just multiply them all the way across, and we don't have to necessarily use the cross product. That was given in one of the videos, and I hope that's correct. That's my assumption here. So if we do that, we have torque max is equal to this 4.9 times 10 to the negative 9 coulombs. And then we have the separation distance, which is S, which is 0.0015 meters. And then we can multiply that by the electric field, which is 2.2 times 10 to the 5th newtons per coulomb. And so if we go ahead and we just analyze our units, we can see that coulombs crosses out, and then we have Newton meters. And that makes sense. That's what torque units usually are. So our final answer will be torque max is equal to 1.48 times 10 to the negative 6 newtons per meter. So that's your final answer. Really the only assumption we made that isn't on the equation sheet is that torque max doesn't necessarily need this cross product, and you can just multiply it through. Okay, good luck.
Can I draw a picture real quick?
Yeah.
So this is what's happening. You have an electric field that,
Let me
can you grab
switch
that? You have an electric field that's going like this, you know. It's a vector, right? It's a field. And it's all going in one direction. And you have this little dipole right here. And it wants to, it's a dipole.
Exactly.
And it wants this flip to go like this, right? Its max torque is going to be when it's at a 90-degree angle to this. So really, if we wanted to use this, it's 90-degree angle, it comes out to this, sine of 90 equals 1, all that stuff. So it wants to do this wants to do that. Those are forces, right? That's what the torque is coming out to be. That's where the torque is coming from, and how a dipole experiences torque.
Perfect. Great explanation. If you have any questions, let us know.